Hello, welcome to the video on finding the area between a curve and the y-axis. Hopefully by now you have memorized that to find the area between the curve and the x-axis, you find the integral on the interval, and it's going to be the exact same thing to find the area between a curve and the y-axis. You're going to find the integral on the interval from a to b. The only difference is because we're finding the area between a curve and the y-axis, your equation is going to be represented in terms of y. So it's going to look like this, function of y dy instead of function of x dx. So let's take a look at what I mean. Here's an example. We're going to find the area of the region to the right of the y-axis at x equals negative y plus 5. So notice, it's x equals instead of y equals, and then everything's written in terms of y. And that's going to be your clue, by the way, that you're finding the area between the y-axis when you have it x equals and the equation's written in terms of y. And so what I did was I went to Desmos and I graphed this just so you could see what was happening. This is the equation x equals negative y plus 5. And by the way, if you go to Desmos, you will need to include the x equals in order to graph it correctly. And so we're going to find the area to the right of the y-axis. So let me put the y-axis on here. Here's the y-axis. And so we're going to find the area of the region to the right of that y-axis on the interval from 0 to 3. And notice y is 0 and 3 are values of y. So this is where y equals 0. This is where y equals 3. And so what we're finding is the area right in here. Now, yes, that's a trapezoid, and you can calculate the area. And we're actually going to do that at the end just to check our work. Just want to show you that it works. So that's the area that we're finding. So the process for doing this, again, is you're evaluating the integral on the interval. So in this case, you evaluate the integral. My interval is 0 to 3, so I've got a lower bound of 0 and upper bound of 3. And what's nice about these, by the way, is that the lower bound is actually lower on the graph. The upper bound is actually up on the graph. So we're evaluating on the interval from 0 to 3, and my equation, my f of y, and notice it's written as f of y because the x value depends on what we fill in for y. X has now become the dependent variable, y is now the independent variable, and so I write it as f of y, and in this case, f of y is negative y plus 5, and then I get the dy there. So in order to find the area, again, we're evaluating the integral on the interval of the function. So the only difference is that the function is written in terms of y, and the upper bounds and lower bounds now represent y values. And so when I evaluate this integral on the interval, of course, to integrate, I add 1 onto the exponent and divide by the new exponent. 5 just gets a y. I have my plus c. And my interval is from 0 to 3. So I fill in the 3 for y. I fill in the 0 for y. Evaluate and subtract. And remember, this is not negative 3, that whole thing being squared. This is 3 being squared and then being made negative. So this is negative 9/2 plus 15 plus c minus, and then 0, any 0 squared is 0. This whole thing is 0, I just have the c. So the c's are going to subtract out, and I'm left with negative 9/2 plus 15. That's otherwise known as 30/2. And so I end up with an answer of 21/2, which you can change to 10.5 or 10.5 if you want. So let's just check our work really quickly because we know how to find the area of a trapezoid. Area of a trapezoid is 1/2 times the sum of the bases times the height. And in this case, this base is 5, this base is 2, so the sum of those bases is 7. The height is 3. And so I end up there also with 21 halves. So it checks out. So while the concept is new, the process is not. This is a process you've been doing again and again and again, and you're getting really, really good at. So again, we're just evaluating the integral on the interval. So let's take a look at another example. This one, we're going to find the area of the region to the right of the y-axis. And the equation that we're given is x equals 1 over y, and we're told the interval from 1 to 4. Again, and it's the y interval, so y equals 1 and y equals 4. So I went to Desmos and graphed it so you could see what we're looking at. And really, you wouldn't have to go to Desmos and graph this, because you know that to find this area, you're evaluating the integral on the interval, and in this case, the interval is 1 to 4, of the function, and the function is 1 over y dy. So you wouldn't even need this graph. All you need to do is plug in your equation and your lower bound and upper bounds. But the graph is good, I think, because it shows you what we're looking at and shows you what we're finding. And so we're finding the area to the right of the y-axis on this interval from 1 to 4. So I'm going to put the line 1 on here. There's y equals 1. Here's y equals 4, mostly. There we go. And we're finding this area right in here. Okay, and so to do that, again, we find the integral on the interval. And so to integrate 1 over y, you use your antiderivatives chart, which I just put up here, and the integral of 1 over x is the natural log of x, so the integral of 1 over y would be the natural log of y. And so that integral equals the natural log of y plus c, of course, and we're evaluating that over the interval of 1 to 4. So we're calculating the natural log of 4 plus c minus the natural log of 1 plus c. And we'll take out our calculators to do that. So I'm just going to do the natural log of 4 minus the natural log of 1. And there's my answer, 1.38. We'll round that to just 1.39. And so, because the c's subtract out of there. And so it equals approximately 1.39. And there's our answer. So, excuse me, let's take a look at another one. Okay, here's number 3, practice 3. And this is not from the writing assignment. This is the practice within the course, the extra practice problems. So in this one, we're finding the area, the region to the right of the y-axis, and the equation x equals negative y squared plus 4. And again, when I entered this at Desmos, I had to enter the whole equation, x equals negative y squared plus 4. I couldn't just enter the y squared, the negative y squared plus 4. You have to enter the x equals. Now, just suppose for a moment you weren't given this interval. Suppose you weren't told the interval. You know what? I'm going to save that for the next explanation. So let's just complete this one the way it was delivered. And so we're finding the area between the y-axis and the interval from 0 to 2. So just from here, where y equals 0, to here, where y equals 2. And so this is the area that we're finding. Right in there. And again, you don't need the drawing. It's nice to see, so you have a visual of what you're doing, but we're just finding the area, so we're evaluating the integral of negative y squared plus 4 dy on the interval, and they told us the interval from 0 to 2. We could have chosen any interval we wanted. We were told the interval from 0 to 2. And so when I integrate, I add 1 onto the exponent and divide by the new exponent. Of course, this 4 just gets a y, the plus c, and then I'm evaluating that on the interval from 0 to 2. So I've got the opposite of 2 cubed over 3 plus 4 times 2 plus c, and I subtract from that the opposite of 0 cubed over 3 plus 4 times 0 plus c. And so this is all going to work out to be zeros, and then I'm going to have the c minus c. So I'm just going to get rid of all of this. And so what I have is the opposite of 2 cubed. So that's negative 8, because I cube the 2 and then take the negative. That's negative 8 over 3 plus 8, otherwise known as 24 thirds. That's the equivalent. 8 is equivalent to 24 thirds. So I can combine those, and negative 8 plus 24 is 16. So I end up with an answer of 16 thirds. So the last thing I want to look at then is the question from the writing assignment. And the writing assignment, question 3, is the one we're going to look at. This is where you're finding the area bounded by the parabola x equals 9 minus the quantity y minus 2 squared and the y-axis. Notice you weren't given bounds. They didn't tell you on what interval you're going to find it. You're just told to find the area bounded by the curve and the y-axis. So we need to figure out where this curve hits the y-axis. And so in order to do that, we're going to graph it. And see where it hits the y-axis, because that'll be our bounds then. And so the graph is x equals 9 minus the quantity of y minus 2 squared. And so there's the graph. And I see from the graph that it's hitting the y-axis here at negative 1 and here at 5. And I know you can't see the whole graph there. Let me just make this a little bit smaller so you can. There we go. Now you can see the whole graph. But again, we're finding the area between the y-axis, which is right here. It's not, but you get the idea. And the negative 1 and positive 5, the place where it hits the y-axis. And so we're finding the area right in here, which means you're evaluating the integral of the 9 minus y minus 2 squared dy on the interval. And the lower bound here is negative 1, and the upper bound is positive 5. You're looking at the y values here. And so my lower bound, like I said, is negative 1. Upper bound is positive 5. And you know that because that's the place where the graph crosses the y-axis. So that defines the boundaries between the y-axis and the curve. And then to integrate this, I actually would first multiply the y minus 2 times y minus 2, because that's what y minus 2 squared equals, and that gets me y squared minus 4y plus 4. Then you'd subtract that, and when you subtract that, you end up with negative y squared plus 4y plus 5. And then you would evaluate that integral on the interval from negative 1 to 5 and calculate the value. And I'm going to let you finish that up on your own, since this is the writing assignment question 3. Let me know if you have questions. Bye-bye.